Okay, so what we're looking at is Chapter 10, Notes. If you remember correctly, in Chapter 10, Notes, I believe Miss Hayner walked you through this when I was absent one day. So if you want to see these notes in full, you can see them on Chapter 10, Notes. This comes from Chapter 10, page 504. I am modifying the assignment. I'm changing it from 81 to 84. I believe it was 81 to 86. So I'm reducing the number of problems that you guys are responsible for and just making sure the content is solid. So on this chapter, in this Chapter 10, we already did the entire chapter. The only thing that we need to go back and mathematically cover is how to calculate the energy involved during the heating up of, say, a solid or a liquid or even a gas. This is called the heating and cooling curve. So I'm going to write that at the top. This is a heating and cooling curve. Okay, so we know how to calculate Q, or heat, when there's a temperature change, or at least I hope we do. In phase number 1 on the diagram, you can calculate heat by using the equation mc delta T. And the reason we can use this equation for heat is because there is a temperature change from the beginning to the end. So if you look at the curve, you're starting at a low temperature, you're going to a new temperature that's higher. So we do indeed have a temperature change, and anytime you have a temperature change and you know the mass of the substance and the specific heat of that substance, you can use Q equaling mc delta T. This is also representing that the fact that the particles here are changing their kinetic energy. Just want to note that. That's different than phase 2. Phase 2 is not seeing a temperature change. So we're starting at a temperature during phase 2 and ending at a temperature. So for this, we're going to calculate Q by using a phase change equation. And it usually looks like this. You take the moles that you're changing the phase of, and you multiply that by the delta H of that phase change. So for example, this would be delta H of vaporization or delta H of fusion. And those values will be given to you on the test or in the homework problem. So can anybody predict for me what equation we would use at 3? Oh, and by the way, this would be representing changes in potential energy where the bonds that are holding the intermolecular forces, that this would be, the intermolecular forces would be weakening. So here in phase 1, I guess we should note that, we would have a solid. And then in phase 2, the solid would be converting to a liquid. In order for that to happen, in order for the solid to convert to a liquid, we have to add energy. But that energy isn't going to make the temperature change, which is evident because the temperature stays the same. Instead, it's just going to weaken the potential energy of the intermolecular forces. In phase 3, it's going to look like phase 1. We again have a delta T, but it's now all liquid. So the entire sample is now a liquid, so we're going to do Q equals mc delta T again, where this represents a change in kinetic energy because we see a temperature change. Step 4 would be a repeat of step. Think about it. Step 4, look at it, step 4. Step 4 has a constant temperature. So should I use Q equals mc delta T or Q equal mole times the heat of the phase change? So hopefully you answered right and you said Q equals moles times the delta H of the phase change. And in this case on step 4, the phase that we would be changing to would be from the liquid state to the gas state. Again, this would be expressing a change in the potential energy stored in that liquid to go to the gas state. And then finally, so this would be liquid goes to gas, and then at step 5, everything is in the gaseous state, and you're just adding energy and making it move faster. So Q equals mc delta T. Now the things that are going to change, so it might look like I'm using the same exact equation and the same exact variables in 1, 3, and 5. Likewise, in 2 and in 4, but I'm not. Here, specific heat is going to be in the solid state. You're going to use the specific heat of the solid. Here it's going to be of the liquid, and here it's going to be of the gas. You might think you use the same delta H, but you don't. Here it would be the delta H in step 2. It would be the delta H of fusion. And this would be the delta H of vaporization. Okay? And then everything else, well, the only other thing that would change would be the temperature changes. So the mass and the moles will always go in as the same two numbers, mass, and then convert that mass to moles. Will always go in as the same two numbers, but then the delta T, it depends on where you're starting and where you're ending. So let's try a problem, and I think the question that we're going to do is, I'm going to cut this off and call it one video so that we don't have a video running too long that takes too long to download. The video that you're going to next need to watch on YouTube is going to be a video of me working through problem, I'm going to do, even though it's going to take a long time, I'm going to do problem 83 with you guys. So again, you have to do problems 81 through 84, and I want you to do 83 with me though. All right? See you in a bit.